Hi, today we are going to study another important operation on matrix, that is matrix multiplication. First of all, what is the need of multiplying two matrices and then how to do it? So let us consider one practical example. Two students, Ramu and Gobu, they are purchasing notebooks and pens as per details below. Ramu is purchasing 5 notebooks and 1 pen, whereas Gobu is purchasing say 4 notebooks and then 2 pens. And the cost of 1 pen is 5 rupees. Then how to prepare their individual bills, their bills separately. Now you know that here we can find two matrices. That is, the first matrix we can take it as say matrix 5 1 4 2. Let it be capital A is equal to. And second matrix is 10 5. Let it be capital B is equal to. So here we have two matrices. That is, capital A is equal to matrix 5 1 4 2 and matrix B is equal to 10 5. Now in order to prepare the bill for Ramu, what we have to do? He is purchasing 5 notebooks at the cost of 10 rupees. So we have to multiply these two numbers. That is 5 multiplied by 10. Then again he is purchasing 1 pen at the cost of 5 rupees. Therefore we have to multiply 1 by 5. Now in order to get to the total amount, we have to add. So that's all. So what I am telling you, Ramu is purchasing say 5 notebooks at the cost of 10 rupees and 1 pen at the cost of 5 rupees. So total bill should be 5 into 10 plus 1 into 5. That's all. In the same way, we can do for Gobu also. That is, in the case of Gobu, he is purchasing 4 notebooks at the cost of 10 rupees. And so we have to multiply 4 into 10 and then for 2 into 5. So in this way, we can find the individual bills. That is, here you can see simplifying 5 into 10 plus 1 into 5, 55, and 4 into 10 plus 2 into 5, that is 50. So this is the amount, 54 rupees amount to be paid by Ramu and this amount to be paid by Gobu. Now at present, the cost of notebook is 10 rupee and cost of a pen is 5 rupees. So that is what is actually, that is the old rate. Why? Because there is a price hike at present. Say let it be 12 rupees for notebook and say 6 rupees for then how to prepare old bill and new bill separately. So again we have to think the mechanism. That is once again very simple. So here for old bill we have to multiply this by the old rate and this by the old rate. So is it? And in order to get to the new rate, what we have to do is we have to multiply 5 by the new rate and 1 by the new rate. That's all. So let us do it. That is, for Ramu 5 multiplied by 10 plus 1 multiplied by 5. That is the old rate. And for new rate, what we have to do? New rate will be, that is 5 multiplied by 12 plus 1 multiplied by 6. So in the same way, for Gobu also we have to do, that is 4 multiplied by old rate plus 2 multiplied by old rate. And for new bill, that is 4 multiplied by new rate and then 2 multiplied by new rate. That's all. So we can simplify, that is equal to 5 into 10 plus 1 into 5, that is 55. So that is for old rate. That is for old rate. And then 4 into 10 plus 2 into 5, that is 50. and new right 5 into 12 60 plus 6, so that is 66, that will be 60 rupees. So this way we can, so this will be the new right, this will be the new right, this is new right, and this about the old right. So this way we can find the old rights and the new right. One thing we can observe very clearly that in order to get this 55, the position of the element is a 1/1 position. Say P11, P for product and 1/1 position. So in order to get to this 55, what we have to do is we have to multiply the first row by the first column. That similarly, in order to get the second element, that is P12 position. P12 position. P12 position means first row and second column. So we will take the first row of the first matrix and then second column of the second matrix. So you can see 5 1 multiply respectively by 12 6. In the same way you can see here, in order to get to 50, what is the cell address? That is 2 1. So second row of the first matrix multiplied by first column of the first matrix, that is second row multiplied by first column of the matrix, second matrix. In the same way, in order to get a P22, what we have to do in order to get a P22, that is second. So we have to multiply the second row of the first matrix by the second column of the second matrix. That's all. So let us see once again what I was telling you. That is, in order to get the P11th position, P11th position, that is very simple, 1 1. So we have to take the first row of the first matrix by the first column of the second matrix. In order to get the P12th position, what we have to do is, in order to get the P12th position, we have to take the first row of the first matrix by this P12, 2 for second column of this second matrix. Then in order to get a P21 position, that is in order to get a 50, what we have to do, that is here 2 means second row of the first matrix, then 1 means first column of the second matrix. Then in order to get this P22th position, that is 60, what we have to do, that is we have to, here 2 means second row of the first matrix, and again 2 means second column of the, that is we have to multiply respectively. That is, I told you, in order to get the 1/1 entry in the product, we have to multiply, that is 1 1, first one for first row of A means first matrix, and second one means second one means first column of B. In the same way, in order to get a P12, here P12, 1 means first row of A and 2 means second column of B. Then similarly, in order to get a P22, what to do? First is 2 means second row of A to be multiplied by the 2 means second column of B. That's all. So in order to get to the Pijth position element, that is Pij element, what we have to do is we have to multiply the ith row of A by jth column of B. Once again, in order to get the Pijth position, we have to multiply ith row of A by jth column of B. That's all. Simply speaking, matrix multiplication is a row column method. Matrix multiplication is a row column method. Matrix multiplication is a row column method. One more thing we can observe in matrix multiplication is that we are multiplying a row by a column. We are multiplying a row by a column. So here we are multiplying 5 1 by 10 5. So you can understand that the number of elements in the row of the first matrix should be equal to number of elements in a column of the second matrix. Once again, we can observe that number of elements of a row in the first matrix, that is 2 here, and number of elements in a column of the second matrix, that is 2 here. Then only, because we are multiplying 5 by 10 and then 1 by 5, so these numbers should be same. That means two numbers here, that is 5 1, and two numbers here 10 5, that's all. On the other way, suppose the first row is say 5 1 and the first column of the second matrix is say 10 5 2, then we cannot multiply. Why? Because we can multiply here, it is 5 by 10 and then 1 by 5, then what to be multiplied by 2. So this is the condition, that is number of columns in the first matrix should be equal to number of rows in the second matrix. Once again, number of columns in the first matrix should be equal to number of rows of the second matrix. In capital A, number of columns, and in capital B, number of rows should be same. Then only we can multiply the matrices. Consider two matrices, say capital A and a capital B here. A is of order 2 by 2 and B is of order say 2 by 3. Here, as I told you, number of columns in the first matrix, that is 2, and the number of rows in the second matrix, that is 2. So these two matrices, we can find the product AB because number of columns in the first matrix, that is 2, which equals number of rows in the second matrix B. So we can perform the multiplication. How it is? That is, first of all, we have to consider this row and with this column multiply corresponding elements, that is 2 into 1 plus 3 into 5. That's all. Similarly, in order to get the next element, what we have to do is, that is, we have to multiply the row 2 3 by the column 0 8, that I want to tell you. That is 2 into 0 plus 3 into 8. Then again, in order to multiply in order to get a next element, what we have to do is, we consider this row with this column. So that is, we have to do 2 into 9 plus 3 into 2. In the same way, we can continue, that is 4 into 1 plus 7 into 5, 4 into 0 plus 7 into 8, 4 into 9 plus 7 into 2. That's all. So this way we can multiply, and you can see what is the order of the product. Order of the product will be, that is 2 by 3. That you can see the first element. This can see the first 2 by 2 order. Then this and this combine, that will be 2 by 3 order. In the product order, that will be the product order. So in product order, that will be 2 by 3. And in order to multiply two matrices, these things will be equal. So simply speaking, we can see that if capital A is of order m by n and capital B is of order n by p, then these two matrices can be multiplied. Why? Because this number equals this number, and AB, product of AB will be of order m by p. That is the first multiplied by the last. So once again we can see, suppose we have two matrices of order m by n and n by p. Are they conformable for matrix multiplication? Yes, because this number and this number should be same. That is, number of columns in the first matrix should be equal to number of rows of the second matrix. Then only we can multiply. And the product order will be m by p. That is, AB is the product whose order will be m by p. That's all. Here we could find a product AB. Then is it possible in this case to find a product BA? So that is B first and A second. So here you can see order of B is, what is, 2 by 3, and order of A is 2 by 2. So you can see that the numbers, that is this and this are not equal. That is, the number of columns of the first matrix and number of rows in the second matrix, they are not equal. Therefore, here we cannot find BA. You cannot find BA in this case. So, that is, in the case of matrices, sometimes AB and BA both we cannot find, and sometimes AB we can find, but it doesn't mean that BA also we can find. So in the above example we could see that AB we could find but BA we cannot, and in some other case AB we may not find but BA we can find, and in some other cases both AB as well BA we can. So these are the cases. So sometimes both AB and BA we cannot find, sometimes only AB we can find, BA we cannot find, sometimes AB we cannot find but BA we can, and sometimes AB and BA as well we can find. That's all. Now we shall do certain questions for homework. The first question, if capital A is equal to 1, 2, 3, 4, 5, 6 and B is equal to 1, 5 column wise, then find AB and can we find BA? And this is a very simple question, you must try. And the second question is that if P is equal to 5, 3, 7, negative 1 and Q is equal to 1702, then find both PQ and QP. And again one more question, that is if A is of order 3 by n and B is of order n by 2, then write the order of AB and can you say the order of BA? Before winding up the lesson today, we shall see one applet made in GeoGebra, that is a simulation for matrix multiplication. Here, in order to get a C11 the entry, we have to multiply first row by the first column, first row of the first matrix and first column of the second. In order to get a C12, what to do? In order to get a C12, that is first row and the second column, first row of the first matrix, second column. Then we can multiply the corresponding entries, and then we can get a 104. In order to get a C13, first row and third column, first row of the first matrix, third column of the second matrix, and multiply corresponding elements. In order to get a C21, what to do? In order to get a C21, that is second row of the first matrix, first column of the second matrix. In order to get a C22, you know that is second row of the first matrix, second column of the second matrix we can get. In order to get a C23, what we have to do is that is second row and third column. That's all. In this way we can proceed. And in order to get a C31, that is third row of the first matrix, first column of the second matrix, then corresponding elements we have to multiply. That's all. In order to get a C32 element, that is third row of the first and second column of the second matrix, we can multiply corresponding elements and add them. And then in order to get C33, you know that what we have to do is we have to multiply by third row and third column. Any element, for example here you can see 2, 3, any element we can find like this. Now you observe C33 means third row, third column. C11 means first row, first column. Now if we change the second matrix to be identity matrix, you know identity matrix means identity matrix is a square matrix in which all the diagonal elements should be 1, 1 and all other elements should be non-diagonal elements should be zeros. So 1, 0, 0, 0, 1, 0, 0, 0, 1, the second matrix. What happened to the product? A into B is A only, where B is identity matrix. A into B is A only, where B is the identity matrix. That is, whenever we multiply a matrix by an identity matrix, matrix will not be altered. The same matrix will be repeated. That is, A into identity matrix. A into identity matrix will be that same only. That is, A multiplied by identity matrix will be A only. Similarly, identity matrix multiplied by A, that's again A only. Okay, thank you for watching today's lesson. We will come up with some other topic next class. Thank you, Bentek.